Hello everyone, welcome to the stream. Welcome to the 16x eval or 16x model evaluation stream. This is a new stream that I'm doing specifically on evaluating different models and their performance. So I realized there's a lot of models that are coming out, and there are also like quite a lot of problems in evaluating their performance. Basically, the benchmarks don't actually align with the actual day-to-day performance or like specific evaluation sets. So I want to kind of share my evaluation result. Yep. So let's take a look. So today we'll be testing out two models. The first one is the gpt-oss-120b. So this is a new one from OpenAI, and the second one is the LM 4.5. That was also recently written. So I'm looking at this, actually this Twitter that says that actually different providers have very different test results for the GPT-OSS model, and this is actually in Korea. So I'm also gonna test out the provider differences for this model to see if I can reproduce this. So some quick notes on this GPT-OSS. There has been quite a lot of reports on like the provider implementation being different or wrong, resulting in inaccurate benchmark or testing data. So if I'm looking at this correctly, Groq actually give a worse result compared to Fireworks or Cerebras altogether. So I think that's the first thing we're gonna test out in today's stream. So we're gonna test out. So the first thing we're gonna test would be the provider differences, the differences between different providers for the GPT-OSS-120b model. So let's see. This is the tool that I'll be using to test my own app. So I have already added a few models for the GPT-OSS-120b. So we have one from Fireworks, one from Groq, one from Together. Fireworks, Cerebras, Together. I think that's a good spread. Maybe we'll add Cerebras as well. So let's go ahead and do that. So this is the OpenAI page, Open Router page. I'll add the Cerebras model as well for the GPT-OSS. So let me just add Cerebras. Okay. So now we have Cerebras, Fireworks, Groq, and Together. These four variants we're gonna test. Let's run a quick sanity test on who are you prompt. See if the Cerebras model is working. So I've already done the test for the other Fireworks, Groq, and Together. This is for Cerebras, and it seems to be working. Active. Yep, so it's working at 800 tokens per second. Interestingly, Groq didn't report it, but that's okay. So with all the setup done, so now we can actually test the differences. So the first test, I think, let me take a look at my evals. Wait, what's happening? Oh yeah, I have something is wrong with. Why is my writing not showing up? Okay. Let's take a look at the writing one first. So I'm gonna create a new experiment called gpt-oss provider or writing. And then going to copy. Oh, okay. Oh yeah, it's technical writing. I just remember. I actually renamed the writing to technical. So let's go ahead and copy one of this into our new experiment. Now we have a reference to test. So the first one we're gonna test is the gpt-oss. So let me make this a bit further to look. Let's test out the gpt-oss 1, 2, 3. I think 1, 2, 3. Wait, I think there's one more. Fireworks Groq, Cerebras. There's one more. Fireworks together. Where is the one from together? I can't really find it anymore. Okay, let's test these three first. Let me see if I added the. Do have the together one here. Somehow it didn't show up. Oh, it's here. Okay. I wonder why it didn't show up just now. Okay, so for this test, we're actually gonna be running the same prompt to these 4 different providers about 3 to 5 times. And we'll see the difference in response, like similar to what this person is doing, and analyze what's the difference between different providers and if they are actually implementing this model correctly. It looks like together is a bit slow. So let me remove this. Okay, so this is the first test. We have the Cerebras at 1771 token. That's this one, 1771. Together is 1618, this one. Fireworks is 1518. And Groq is 1304, right? So that's the first set of results. I'm gonna repeat this 3 more times. So these are the 4 models. Run it again. And then we're gonna keep running this until we get 3 sets of results, and we will be comparing the output. This is to establish the performance of different providers. That's the second set done. Let's run it the 3rd time. 4. Okay, so apparently together is quite slow. It's like significantly slower than the other providers. So if we sort by speed, we can see the bottom three are all together. And then Fireworks is slightly faster. It's like kind of normal speed for this small model. Groq is faster at 300, 400 tokens per second. And then Cerebras is the fastest. I happen to have the evaluation function for this task. So it basically counts the number of words that we expect from the output. So for this task, it will be the terms that we expect from the output. For writing tasks on AI, so it will be like the terms that we want to include as an eval function. So there are 20 terms in total, and we can see that these are the top models that got 14, and then these are the models that didn't do too well. Let's take a look at per provider, for each provider, the response. So for Cerebras, we can see the token count varies quite heavily. So this is a very short response, and this is a much longer response. Yeah, it's definitely much longer. Interesting. And the output, the result is like this. And then for Fireworks also, the output varies. Interesting. For Groq as well, the same. Together, the same. Yeah, it looks like the output does vary quite heavily from 1000 to 2000 tokens for all the providers. Which suggests that this model itself has a very large variance in terms of output. It's not related to the provider. So that's for the writing task. I think we cannot draw very definitive conclusions from this. It looks like all the providers have some kind of variance, and all the token counts are kind of in the similar range. Yeah, there's no one provider that stands out in terms of quality or tokens. But it's interesting that the bottom two performance are all from Cerebras, right? In terms of the inclusion of facts. So if we were to actually give rating to each one, so let's do that. Let's give the rating to each one of these. So I do have a rubrics for this. Let me just add the rubrics back and add the evaluation function. So if we were to rate, then nine terms would be quite low, right? It would be an 8 out of 10. And this also doesn't adhere to the correct format, so it will be missed points and wrong format. So that will give this response a 7.5. For 11 points, it's the same, and this format is also wrong, so it's the same point, 7.5. This is also the wrong format. Interesting, all of these use the wrong format. This one also the wrong format. 11, 12 also wrong. So far, looks like all the response have the wrong format. Yeah, some of them did have the correct format. So this is 12. Still wrong format. This is still the wrong format. Looks like very consistently using the wrong format. Okay, so this one looks like the correct format. Oh, it's still missing the empty line between each term. So you can see here, it doesn't adhere to this format. So even though there are like new lines between the title, unlike this, which don't have the new lines after the title, this one have the new line after the title, but it still uses the wrong format. So this will get 13, which is major points, and wrong format, which would give it an 8 out of 10. And the same, 13 points. 13 is 5, and use the wrong format with 8. You can see I'm doing the manual rating. Okay, so this one is interesting. It adds this new markdown separator between the year. It wasn't in the requirement, so I'm going to have to mark this as the wrong format, even though it's a nice thing to have. So it covered 13 points with the wrong format. That would give it an 8 out of 10 as well. This one is obviously wrong, but it did cover 14 points. 8. This one is also 14 points. So none of this actually got the exactly correct format. Yeah, you can see it's not. We cannot make any definitive conclusions on like which provider is better than the other one. They all seem to perform similar with certain kind of variance for this task at least. So that's interesting. So the conclusion from this is that I'm gonna take some notes. So for GPT-oss variance test, we have the writing task. All providers exhibit variance in response length and rating. Right? So there's no single best provider for this task. The speed is self-explanatory. Speed is very different. Okay, so let's move on to a coding task. Let's create a new coding task to test. So I think for this one, which one should we test? I think the benchmark visualization one is probably the most interesting one to test. Basically, so the benchmark visualization test is basically a task for the model to generate model benchmark results. So these are the past results that I've generated for different models, and we'll see how well it generates. Right? So this one we should be able to see some variance of how they look like. Let's create a new variance benchmark. Okay, I'm gonna copy one of. We're gonna run this experiment on all of the GPT-oss models, so all 4 of them. I think for this task I'll only repeat twice because each one takes quite a lot of time to review. Let's see. Let's run it for 2 times first. So again, we run for all 4 providers. Yeah. quit all this. Okay, so all of them have finished. Let's render all of them and see how well they perform. So by the look of the output tokens, we can see they are quite similar, right? So that's interesting, because previously for the writing task, output tokens are very different. So for this one, it looks like they all have very similar output tokens. But in terms of characters, together has only 4,000, whereas the other one has 6,000. Okay, so let's render all of the. I do have a folder that we can put all of our code inside. So the first one would be the Groq one. So let's put this. One on HTML. This response, so we can see that it's wrapped by the HTML tag. Expected. And then we're gonna open our browser and see what it renders. Okay, that's interesting. It's kind of a normal looking bar chart. I think it's quite similar to one of the ones generated by Kimi K2. Yeah, quite similar to the one generated by Kimi K2. Or Groq 4. Very similar to Groq 4. But it doesn't have the labels, right? So it's missing the labels. So let me take a screenshot of this and then give it a rating. Okay. So this is the gpt-oss from Groq. (120b) from Groq. Okay, let's see how well should we rate this. I think I have the evaluation rubrics as well, so let me just quickly copy the rubrics. My new experiment. It is. So it is a baseline visualization without label. That's 8 out of 10. And it's colored by model. Wait, it is actually a side-by-side comparison, right? It's not a, yeah, it's a side-by-side comparison, so it's 8.5, and then it's colored by a model, which is minus point. Side-by-side, color by model. So that's 8. That's 8.5 minus 0.5, which is 8. So that's 8. Okay, so that's Groq. Let's look at Cerebras. Oh, Cerebras even has emojis inside. Oh, that's crazy. I don't think I've ever seen an emoji inside a code for this task. Ah, okay. Let's see how well it does. Let me create a new file. Oops, not this. gpt-oss Cerebras1.html. Yeah, so this is Cerebras. And let's see how well it renders. Oh, okay. It's completely different from the one rendered by Groq. And it's not a side-by-side one. But it does have labels. And I think oh wow, it does even support this. I think the top 3 have the more bold outline. Yeah, I think so. Yeah, that's interesting, right? And that's quite interesting. That's pretty good. I think that's pretty good. So this is the one from Cerebras. Obviously, these tasks have some variance and some noise in terms of output. In fact, a very large variance and noise. But I think with enough runs, we can get a good sense of what the model can do. So this is the gpt-oss-120b from Cerebras. Okay, you can see it's very different from the one generated by Groq. Yeah, so let's rate this one from Cerebras. It's a baseline visualization. And it has clear labels. So it's a baseline with clear labels. That would be 8.5. Yeah, with clear labels, 8.5. Okay, cool. That's 2 down, 2 more to go. Next one is from Fireworks. Let's see what Fireworks gave us. Okay. It seems like there's some bug. So there's a small bug, but this is quite normal. I've seen this happen quite a few times due to how this one is set up. Yeah, basically you're not supposed to redeclare the models. Okay, let's see. That looks pretty nice. The label is overlapping, but that's quite minor. But the color is nice. So I think it's very close to the one generated by Cerebras. Yeah. I think I'm not gonna take screenshot of every one. Just gonna take screenshot of the one. Never mind, I think I'm just gonna take screenshot of all 4, at least for the first run. So this is gpt-oss-120b from fireworks. Okay. So it's basically very similar to Cerebras, just the difference between how the label was done. I think this one from fireworks looks slightly better, but I'm not gonna give different rating for which one looks nicer. It just depends on the features. So one is basically clear labels, so that's the same. And the last one is from Together. Let's see the Together one. Interesting. I think it's the first time I've seen a star on the bar chart. Clearly the height is a bit weird. So this one is from Together. Label this graph Together. I think this can still be attributed to variance, but let's run this test multiple times to see if we can attribute this to variance or it's actually the difference. So I would say this is too narrow. It's a baseline graph with labels. So 8 plus 5 minus 5, that would 8. Okay. So let's try to run this test again to see if we can reproduce the similar output from each provider. Cerebras and group are fast, then should be fireworks and together. So let's order by the model and see if the Cerebras second attempt is the same first one. Second. Okay, so this is the second one from Cerebras, and this is the first one. Looks very similar. Looks very similar. I'm not sure about the strike through lines, but everything else looks very similar. Yeah, so basically it will be the same rating as the first one. Okay, so at least there's some consistency here for Cerebras. It should be 8.5. Okay, so the Cerebras one is quite consistent. Let's look at the fireworks one. So the first one is like this. Let's see the second one. I'm also seeing these emojis. Okay, so it's not unique. The emoji is not unique to the provider, but it's unique to this model. Okay, let me make a note here. For benchmark stars, close Cerebras fireworks if emoji encode, suggesting this is not unique to provider, but this is not unique to provider, but a characteristic. Characteristic of the model. Okay, that's interesting. So we have the fireworks one here. Let's open this. Okay, so this is the same problem that I had with another model where it just keeps rendering. I think it's the horizon alpha, something like that. So it doesn't actually work. I think I've seen this before with some, let me see. Was it fireworks? Or Kimi K2? I remember I had this problem with some of. I don't remember which model I run it with, but I had the exact same problem. Okay, so basically it didn't work. Didn't run. Can stop rendering. Yeah, but this could also be due to a variance, so we're not sure yet. Let me see, give another try. I remember having this problem. I don't remember which model had this problem. Let's try the fireworks one again. Because this is clearly something that is not supposed to happen. And it's too large of a variance. See this third. Okay, so this one does render. And it's a side-by-side one without labels. So it does work. So this one becomes side-by-side, color by model. So that's a 8 out of 10. And take a look at the Groq. It didn't actually work. Okay, so it's same bug. Okay, so this is one from Groq, second time. Okay, so it's basically the side-by-side thing is not unique to the provider, it's also based on model. So this one looks very similar to this one, right? Yeah, so the Groq one looks very similar to the Cerebras one. With label and not side by side. Okay, so I think we are seeing a very clear trend here. So all the different providers have they don't have a unique set of output, so it's more like they are very the output is model dependent, not provider dependent. I can say so. It's not provider dependent. All providers can generate similar sets styles. Yeah, so I think that's the conclusion. Let's take a look at the last one from together. Okay, that's interesting. This is a new bug I've seen. This is a new bug. Okay, so it's using a plugin, but there's no such thing. Let's remove that. Oh, okay. So this is similar to this one. Okay, so all the together. This is interesting. So all the together visualizations are all narrow, but this doesn't happen for other providers. So there are some interesting provider specific on here, unless it's like some extreme kind of thing. And so for both times the provider the together provider has produced a very narrow benchmark result, whereas all the other providers doesn't have this problem. Most attempts on together provider produce a narrow. It is narrow. I think it's narrow. Only occupied top half of the screen. Top 1/3 of the screen. I think so. This is very interesting. So does it have labels? No, it doesn't have labels, right? Okay, so that's gonna be lower. That will be 7.5. Okay, looks like we do have some trend here. So Cerebras, Fireworks, Groq. So the Cerebras, Fireworks, and Groq are are more consistent, barring the one bug with Fireworks. So Groq and Cerebras are quite consistent. Surprisingly, Cerebras consistently generated 8.5 rating, whereas Groq consistently generated 8, but I don't know if this is significant enough. One thing that is very clear is that together generated narrow visualization. One attempt from fireworks did not render properly. Give it another chance. Okay. But was it the same for the writing? No, right? No. It wasn't. Yeah, so the writing one was not significantly different. So in terms of rating, Cerebras gave the best rating. Best average rating for this task. And for the writing task, which one gave the best rating? I think Cerebras, firework, and together. The firework gave the best rating, best average rating, but it's very narrow, right? So I think Cerebras, fireworks, and together okay, got at least one rating of 8. Okay, so based on these two evaluations, I think we can safely say that Cerebras is one of the better ones. Reliable provider. Based on the limited data. Best. So the reason why we want to know to pick a provider is to do the subsequent evaluation on other tasks. So now we know Cerebras is the best provider. We can use it for the new tasks. Okay, so let's close all this. Yep. Cerebras. Okay, Cerebras. So we're gonna so here so now we're gonna do the actual testing of gpt-oss-120b using Cerebras as the provider. So we're gonna pick the average rating from one of these into our proper benchmark. So because it's 8.5 majority, so we're gonna pick 7.5 majority, so we're gonna pick 7.5 into the main benchmark experiment. and experiment. And for benchmark visualization one, we will use either one is fine. Pick one. We'll go into our main evaluation. Okay. And we'll test testing. So now if we go back to benchmark, so we can see we already have 2 tests completed. Now we just need to do the other tests. Okay. Let's do the clean markdown one first. I think it doesn't really matter. So this one is mostly, this test is mostly on TypeScript. Yeah, so basically writing some logic to clean markdown. So when given an input of a markdown format, it will clean it into a plain text format like this. So this is what this task is. So it will be expected to write something like this. Let's see how well our model does. Okay, I mean this one does have some variance. I might be inclined to run it twice. The code looks okay. It's not significantly longer or anything. Yeah, so we need to evaluate this. Add it to testing. Run the test. Okay, so it outputted true. This means that it passed the test. So you can see this is the output that it generated. So it generated a perfect output. So inside our rubrics, you can see that the correct output is 9 out of 10. The code is, let's look at the code. It's actually quite short, right? 1, 5, 4, 8 characters. It's not particularly short like this one. It's not particularly short. So I'll just give it 9. Let's all make the node have the same node. This is a 9 out of 10, which means that it's actually better than GPT 4.1. For completeness sake, let's run this again to see if we can reproduce the same response, or is there a large variance? Because this model, I think it does have some kind of variance. Let's give it a try to run it again. Oh, okay, so this time around it generated a much longer response. Interesting. So it was 1548, now it's 1885. This is much longer. So you can actually see if I compare these two. The one on the right is much longer. Okay. Let's see if it works. Okay, it didn't work. They had one new line issue. Okay. One new line issue, that will be 8.5. I think the benchmark would take the highest rating. Yeah, it took the highest rating. I think that's within the variance. We'll take the higher rating. I think I should also make a note. In markdown, got 9 and 8 out of 5. Took higher rating. We need to be consistent about this. Yeah. Should we take the higher rating or should we take the average? I think it's better to take the majority rating. Take majority rating. So let's try to run it 3 times and take the majority rating instead of just the highest rating. To be more consistent with what other models are doing, because other models only got 1 chance, right? Okay, that's cool. Okay, so now it generates 2. Okay. But 2 differences is the same as 1 difference. Yeah, I think 2 differences is the same. 2 new line issue. It will still be 8.5. Yeah, so let's take the majority rating, which is 8.5. I think how to handle this. Because here it will actually take the highest rating. Yeah, it's very tricky to design this kind of evaluation, because other models only had 1 chance. But if we want to control the variance, we should allow each model to have multiple chances and pick the majority rating. So I think the correct thing to do is to just take the 8.5 and then remove the rating of 9 and 8.5. Let me create a new experiment called graveyard. Move this to the graveyard. Doesn't matter. Yeah, so I think we need to be more consistent with our standard, right? We take majority rating. Take majority rating 8.5. Okay. Because if we take the highest rating, then it's not fair for the other models. So for the other test, I'll just do one run. You can see this evaluation is very hard to do scientifically, but I think if you have enough data, you can kind of average out. If you have enough tasks, you can get a good average rating. But within each task, it's quite hard to rate which model is better because there are variants, right? I think though the better way would be to have a error bar here. Maybe that's what I'll add. I'll add like a error bar and range here, and then give the average. I think that's the better way to do. But for now, it will just be a 1 rating for each task, and then we take the average over all the tasks. So this one looks like it's correct. Yeah, looks like it's correct. Okay. So correct. Does it have extra logic? No, I don't think so. So 9 out of 10. Okay. It's not particularly verbose, and it's not particularly concise, right? So it fits right between these two. So if it's like 600 characters or 1000 characters, it will be very concise. And if it's like 3000 characters, it will be verbose. I guess this is also considered verbose. It's a little bit verbose. Yeah, it is a little bit of verbose because there's no changes to be made on this part, right? It's actually a little bit verbose. But it's not as verbose as this one. So maybe this rating was not fair to Kimi K2. I need to revise this rating. Or revise our benchmark. Verbose output 0. think this is okay. Why does this look much longer than this? Compare the output. Oh, this one has reasoning. Okay. It's about the same length. Yeah, I think this one I have to revise the Kimi K2. It's not verbose. I had to revise this to give the Kimi K2 a higher rating, which is 9.25. Okay. So that brings up the Kimi K2's rating. Let's see. By a little bit. It's still 7.2. Still 7.2 on average. That's not changed. Okay. I think in my previous evaluation it's also 7.2. I can't see it here, but yeah, I think it was 7.2. 7.1, right? Previously it was 7.1, now it's 7.2. Not a big change. I think it's fine. Let's move on to this one, TypeScript specific task. See how well this one does. Looks like it didn't get any automatic rating, so that means it's probably wrong. Okay, that's a very long explanation. I can tell this one is wrong. Use a kind discriminator. Okay. I haven't seen the second solution, I must say. This second solution is a new one. It's add a separate kind discriminant. That's interesting. Yeah, that's interesting. That seems like it should work. Let's test this out. That's interesting. This is the first time I've gotten a new response for this task. Let me make a quick note. So we have our folder watch for 9 out of 10. Okay, cool. And then we have our previously done benchmark. This we're gonna take the Cerebras rating of 8.5. And then this TypeScript narrowing, it actually gives us a new method that I have never seen before. So we're gonna test this out, see if this works. Let's see. So this model is gpt-oss-120b from Cerebras. So this is the first solution that it gave us. The first solution, like this. Okay, looks like it doesn't work, but let's see. Second. Okay, actually I should copy paste the whole thing because the formatting is a bit weird. So this is the first. This is the first, and this is the second solution. It did give us a very long explanation, which is okay. For this task, I specifically did not ask the model to omit the explanation. Okay, looks like the second one works. But just to be sure, let's run the test. Using TypeScript compiler. Let's try the first one. Wrong folder. Okay, so the first one failed. Try the second one. The second one passed. So as expected, give two solutions. First one did not work. Second one works. Okay. And it's using a new type of method, right? New discriminant using kind discriminant. Add a separate kind discriminant, which is a new method I've never seen other models use, which is interesting. Okay. So let's move this first. So this one is wrong. This one is right. I think this is actually very elegant solution. Let's see if other models came out with similar. No. Oh wait, I did came out with this solution. Yeah, this was the solution that I came out with, but no models seem to have came out with this. Yeah. Okay. Is this though? Okay. So yeah, so let's do the rating for this task. They did provide a working method. Second method works. So that's 8. Provided multiple methods and one method is wrong. Which is not the final answer, I guess. Yeah, it gave two solutions, not like the first one and final one, right? It's the first one and the second one, so both are parallel. So there will be 8 minus 0.5 for one wrong method. That will be 7.5. Okay, that places it ahead of almost all the other models. which is interesting. I'm tempted to run this again, but I know I have to deal with all the variance and other problems, so I think I'm just gonna leave it like this and think about how to improve the evaluation process later. Which leaves us to the last one. It looks like it's actually gonna beat Kimi K2. Let's try this one. I mean, this one is relatively simple, so it's more about testing the instruction following. It did not do well on the automatic evaluation. Okay, looks so. Oh, it didn't use the default now. But it's fine. This is also fine. So I only output changed code, I think so. Let's see. Compared to 1, 1, 2, 4, 1, 6. Okay, so that's a little bit long. It's somewhere here. It will be follow instruction and goals. Okay. Okay, if we look at the benchmark, it's if we just look at coding, wow, it's actually ahead of GPT 4.1. Okay. Not sure how to not sure how to make sense of this. I don't expect it to be better, but let's see. Maybe it just got lucky with the TypeScript narrowing task. I should have tested more times. Maybe I should have tested this particular task more times for all the models, because it has such a large variance from 1 all the way to 8.5. Yeah, I think I'm gonna do that actually. Give other models more tries to reduce to mitigate variance. Give newer models. Okay, let's try this task again to mitigate the variance. And then for this task specifically, I think we are going to change the rubrics on how we rate this. Yeah, I think we need to change the rubrics on how we rate it. So this is the current rubrics on how we rate this. I think because of the large variance, I have to give each model at least 2 tries. Yeah. Additional instructions. Each model is given 2 tries for this task to account for variance. Large variance in the higher rating will be picked. Higher rating will be, yeah. Yeah, I think so, right? So this makes more sense. Yeah, I think we need to change these rubrics. This looks much better. But we only need to do this for the newer models. We don't have to change all the models. Okay, so with this new rubrics, let's run this task again for all the newer models to give them a fair chance, right? Okay, so this is the first attempt. I'm going to do this the same thing again. This is some very old test. Let me just remove. Okay, let's see the second. This doesn't seem to work. AppGuard function. Okay. So I think again the first one doesn't work and the second one works, if I'm not wrong. But let me try. So this is 1-2, 1-1, and we 2-1, -2. Okay. So for the 2-1, -1. -1, -2. Okay, it's missing the definition. It's actually missing the definition, but doesn't. Somehow my copy function. Okay, so that looks. Okay. Is this what the model said? Yeah, okay. Let's test this too. First one is wrong. The second one is right. Okay. So it's the same, exactly the same, which is very consistent. Okay. That's a good sign. That's a very good sign. So it gave a different solution, but in both cases, the first one didn't work and the second one worked, which is quite cool. For this task. We'll try. In both attempts, give two solutions where first one, the second. In one try, it suggests a new method that no other model came up with. One of the solutions. Okay. So, okay. So that's for this model. And now let's test the other models that didn't do very well. I think we will test the Qwen 3 coder. Where is it? Oh, this one, right? We test the Qwen 3 coder and the Kimi K2 to give them both a second chance because they are quite new. So let's do the Kimi K2 first. Again, the first one is, the second one is, and we create a new one for Kimi. Okay, I think this took a little bit longer than I expected. Spent 1.5 hours just testing the OpenAI one. Don't think we have time to do the GLM 4.5. Maybe we'll leave it to the next stream. Yeah, I think it's better, right? If we have one stream for each model. So I'll just finish this Kimi K2 testing to complete our updated rubrics. Okay, so Kimi K2 gave us one response, which is still wrong, right? This is still wrong. I'm pretty sure this still doesn't work. So let's see. Yeah, so this still doesn't work. So we give it 2 tries and both of them are wrong. There's nothing we can do here. It's just wrong. Okay, that makes me feel a lot better because I thought the variance is gonna increase the score, but it didn't, right? So actually what we did for this task before was okay, at least for Kimi K2. Running the test again didn't improve it. Giving it more tries didn't improve. Okay, so this one, the Qwen 3 coder did offer 3 options, right? To exclude this one doesn't work. Reorder the union, what the hell? That's crazy. That's crazy. I don't think any of this would work. I actually don't think any of let's try it out. Two point 1.2. Okay, so these are the 3 solutions. Copy. They didn't even give me the code. They didn't even give me the. I have to construct this manually. Is my space. Oh yeah, now this looks correct. Okay, so this is the original question. Need to initialize this. Why is all my copy pasting? It's very weird. Okay, so these are 3 different setups to apply these fixes. So this first fix. I don't think it will work. Let's try. Oh, they have. Okay, didn't work. Okay, let's try the second option. I doubt this would work. It didn't work. Try the third option. I think also doesn't work. Paste this finally. Oh, I forgot to change this. So it doesn't work. Oh, model output. I deleted the model output. Oops. Okay. Now it has model. Okay, it doesn't work. Okay. Doesn't work. So all 3 didn't work. All 3 methods work. Okay. So it's 1 and then. So it's 1 didn't work, but our lowest rating is 1, so I guess we can only give it 1. Yeah, we can't go lower than Okay, so that actually didn't change the rating at all, right? That's interesting. However, this did not affect the rating for new models. Kimi K2 and Qwen holders still both got 1 out of 10 rating after giving them a second try. Okay, that's good. That's good. That's really good. So we validated our original process was working fine, right? It didn't actually cause any issue due to variance. That's really good to know, and it validated that all our results are valid. And actually, GPT-oss is better than GPT-4.1, at least in our benchmark. That's crazy. It's only slightly behind Sonnet 4. Okay. Seems to be too overpowered, but that's the conclusion for coding. And then for technical writing, it's also not too bad. I think it's about the same. Yeah, it's... Oh wait, it's actually worse. Yeah, it's worse than GPT-4.1, I think. Okay, so there you have it. It appears that this new model from OpenAI is actually very good. It's just behind Sonnet. Let me add back my book. So if we add back Gemini and Groq, we can see that it's actually ahead of GPT-4.1, ahead of Groq 4, ahead of Gemini, and ahead of Kimi K2. Not to mention Qwen coder, which is further behind. It's just slightly worse than Sonnet 4 and Opus 4. Okay. A very interesting result. I would not have expected. I would have expected it to be worse than GPT, but it turns out to be better. It's kind of crazy. So yeah, so there you have it. I will post this result on my website soon, and I will also do the GLM 4.5 evaluation very soon, probably tomorrow. Yeah, thank you all for watching.